this completely contradicts the implicit theory of mind idea, because you can't ascribe a belief to an arrow. It's completely inanimate, whereas the avatar you can. It's a person, supposedly. But if you find exactly the same results with an arrow, it's clearly not anything to do with theory of mind whatsoever. It's something to do with the presence of the arrow that's distracting you, or the presence of the stimulus that's distracting you. And so this is a perfect example of, essentially, you always need control conditions in psychology studies. You always need to be careful about what conclusions you draw from things, because it's easy to draw a conclusion of implicit mentalizing from that first study, but until you've tested whether it's something entirely lower level, then you can't make that conclusion definitively. And that's what Celia Hayes argues in that paper that I suggested, in that if you want to improve this research area, you need to include inanimate control conditions in all of your studies, essentially.
Sorry, I have a question on this.
Yeah.
So, I mean, we are intentional systems, so we automatically, so this is Dennett's idea, Daniel Dennett's philosophy. This is we normally attribute desires and beliefs to inanimate objects automatically also because of theory of mind. And evolutionary is beneficial because, so in the evolutionary environment, it will be like, it's better to attribute, theory of mind to even inanimate objects if they're say big, since animate objects are kind of salient and important to us. So it's, so for example, even if I see a rope, it's better to bet that it's a human being.
Okay.
I don't want to mistake it for a snake. So
I mean,
we do this sort of thing all the time, like in computers, I curse my computer, I look at my computer, and then we see dots and spaces. So we do that all the time.
Yeah, we see dots and spaces.
I don't see why the arrow condition should be a contradiction, because we might actually anthropomorphize the arrow.
Fine, maybe the psychologists in this case haven't been reading the philosophical literature.
No, this is in the psychological literature also.
I guess I've read this study, and yeah, as I said, the whole premise was that the arrow is completely non-social, and theory of mind is meant to be something social. And I know you just said we can ascribe theory of mind, we can use theory of mind on inanimate objects, but I've not necessarily come across that in the studies that I've read on this. I think from the psychologist's point of view, this is kind of like a very important distinction between having something that's social and something that's inanimate. Yeah. At least the psychologists that I've been reading in this field.
But it's still underdetermined that we are not anthropomorphizing the arrow. I mean, that hypothesis.
Yeah, we could be anthropomorphizing the arrow, but I don't know. Is this then you could argue in that case that maybe if autistic people, in fact no, we haven't done any studies with autistic people with these inanimate control conditions. I don't know, fine, maybe that does introduce an element of uncertainty, but I think the whole point was that it's not the full story just by looking at the avatar. And even if you do say that, okay, we ascribe beliefs to inanimate objects, I think this adds more to our understanding, and we can leave that caveat there. Like some theorists might argue that this doesn't mean anything because we still ascribe it to arrows, but again, is that beneficial, especially in this case? I'm not sure. So yeah, we're starting again with the second half of the lecture. So we've discussed the implicit theory of mind system, and then another reason why people might struggle to draw conclusions from the theory of mind literature is that we struggle to measure theory of mind. So the idea is that the non-universality and specificity of theory of mind deficits in autism may simply because the false belief tasks that we use, like the Sally-Ann task, just aren't sensitive enough to detect deficits. As we saw, I showed you an example of the Sally-Ann task. It's pretty bloody easy. Like, most people could do that, and the idea is that they're just not sensitive enough to detect deficits that are there, because they basically assess it as a binary pass or fail outcome, and therefore they can't measure like anything like the extent to which people have theory of mind, something on like a continuous scale or spectrum, for instance. And therefore, autistics may develop enough theory of mind ability to pass explicit false belief tests, but yet lack enough theory of mind, like the level of theory of mind that neurotypical people have. Or they might use these compensatory reasoning strategies to pass false belief tasks, even if they don't have theory of mind, because you can easily pass these false belief tasks using like simple rules that help you get through the task. Either way, theory of mind is likely still impaired relative to controls. How else might we measure theory of mind other than false belief tasks? So until very recently, most people just assessed the individual differences in essentially more or less complex ascriptions of beliefs, or ascribing beliefs. So this was thought to represent the difficulty of the theory of mind task, and it was based on developmental trajectory. So basically, as neurotypicals go through their childhood development, we develop some abilities earlier than others. So I'll show you this on the next page. You can see here that we understand that people have different desires earlier than we understand that they have different beliefs, and we understand that people have different access to knowledge. So for instance, the example here is the child sees what's in a box and judges the knowledge of another person who doesn't see what's in the box. So as I said, that's basically the Salian task. We get that later than the diverse beliefs, and then the false beliefs we get later, explicit. And then, for instance, this is one of the last ones that develops. Child judges that a person can feel one thing but display a different emotion. Things like emotion regulation, altering their facial expressions to show something else that's different to what they feel. But there's a developmental trajectory to this, and some of these abilities develop later than others. And this was used as like an index of difficulty of these different types of theory of mind. However, we now have this new approach to measuring theory of mind called mind space, developed by Conway, who's in Jeff's lab. I'll talk about Jeff later, I think. But the idea is that we represent other people's minds as vectors in like a multi-dimensional psychological space. That sounds quite complex, but hopefully some diagrams will make this more obvious to you. So the idea is that minds differ along numerous personality dimensions. So for instance, if I look at people in this room, one person here might differ along their, say, conscientiousness, another might differ along their extroversion, another might differ along their suspiciousness or their lack of trust for other people, another one might differ along, I don't know, their various other dimensions. That forgetfulness is one here, intelligence for instance, and we have all of these different dimensions to our personality, to our minds, that people vary along a continuum, right? As I said, if I put you all in a room, I could probably put you in a line as to how extroverted you are. There's individual differences in that. And so basically Conway et al. Took inspiration from face space, which this is a really old concept where different faces have different features, so like the wideness of the jaw, the wideness of the mouth, the eyebrow ridge, that type of stuff. And people vary along a continuum along each of these. And this is one of the theories that has been put forward to explain how we recognize other people. They're just located somewhere on a face space, and we associate a certain identity with a certain location on a face space. But they did this with brains. So as you can see, some people are more intelligent, less intelligent. Some people are more trusting or less trusting. Some people are more reckless or careful. But the idea is, the important thing that this captures in both the face space and the mind space is that certain dimensions correlate more with one another than others. So for instance here, a narrow jaw correlates with a narrow mouth, as you'd expect, and a wide jaw correlates with a wide mouth more often than not. For instance, someone with a wide jaw is likely to have a wide mouth. And the same here. The idea is, this is just an example, a toy example, but the idea is here that someone who's more careful is likely to be more suspicious, for instance. And these traits correlate. So the idea is that we have these, in our brains, we understand other people's minds, and we understand that people vary along these continuums. And so by this mind space account, individual differences in theory of mind may be more meaningfully attributed to like different factors. So for instance, we might be inaccurate, we might be bad at locating where someone is on this mind space. So we might think that they're extroverted when they're not, for instance. It's poor locating on this mind space, this multi-dimensional mind space. Or we might have problems with representing minds and mind space, or we might have problems with working out the correlations between different traits, for instance. And therefore, if we think someone is extroverted and we think extroversion correlates with, say, quietness, which it probably doesn't, then we're going to have more trouble working out the intentions and beliefs of someone else. And therefore, we can measure mind space by calculating how accurate people are at making these trait covariance judgments, which is basically viewed, according to these authors, as like a surrogate stand-in for a proxy, almost, for theory of mind ability. So as we said, accurate inference of the contents of another person's mind is likely helped by representing multiple features of their mind, multiple dimensions. The more dimensions we can represent, the better. So this is just an example that they put in their paper, and you can see here that first of all, people might have differences in placing people on this mind space spectrum. So for instance, person A here has said that, the person 1 here has said that person A is up there on extroversion and up there on conscientiousness, and person B is there. This person has put them in completely different places. So there's individual differences in where we locate other people on this mind space. And you can also see there's individual differences in how we see these traits co-vary with one another too. So you're saying that people's differences in terms of their theory of mind ability can be attributed to various different factors, including essentially how they represent the traits of other people and how they represent the covariance between traits. And it makes it a lot more meaningful when we talk about good or bad theory of mind, to some extent. Oh, this is a very new theory, so there needs to be a lot more work done, but it's a lot more promising than false belief tasks. Anyway, so the whole point you should have got from all of that literature on theory of mind is that it's quite complicated. I personally don't think that autistic people clearly do have difficulties, problems with understanding the beliefs, intentions, desires of other people, but whether that explains the whole condition is massively up for debate, and I don't think there's anything conclusive that suggests that it does, either from implicit mentalizing or from explicit mentalizing. So the second classic theory to explain autism is this executive dysfunction theory, and we'll go more into it. So executive dysfunction basically means that people are impaired at using their executive functions. And the executive functions are this array of higher level processes, such as planning, flexibility, working memory, inhibition, that we have to use all the time to, say, multitask, to keep things in mind. It's our executive functions. You can see here, this is a diagram of them. We have flexible thinking to adjust behavior to unexpected changes, emotional control, impulse control, organization, task initiation, planning, prioritizing, self-monitoring. So evidence from frontal lesion patients. This is one line of evidence that's been used to support this executive dysfunction theory of autism. So patients with frontal lobe lesions tend to display symptoms characteristic of autism. So there's like an equivalence here between frontal lobe patients and autistic people, such as these repetitive and socially inappropriate behaviors. The classic example is Phineas Gage, who is, apart from HM, probably the most famous case study in all of psychology. And he was a railroad worker in the USA. And there was an industrial accident, and this is taken from, I think this is taken from an X-ray or something that they did at the time. But basically he had this steel bar that went straight through his skull, straight through the top of the skull and out the other side. And that kills, obviously, 99.9% of people. But he somehow survived. He survived, and you can see this is him here holding the bit of metal that went through his skull. You can see, obviously, it damaged his eyesight. But this is an extremely important case study because he displayed behavioral traits after his accident that were very characteristic of autism. So he really struggled socially. He had these repetitive behaviors. He became a completely different person, and it took out his frontal lobes. You can see here, it took out his left frontal lobes, went straight through it. And the idea was he then showed symptoms that were more like an autistic person to some extent. And then we also have evidence of planning impairments in autism. So planning, as I said, involves things like monitoring, updating, and reevaluating your intended actions. And there's this study by Hughes. Hughes has done so much research on this theory which they use the Tower of London task. So this is the Tower of London in London, obviously, very famous. It's where the Beefeaters are. And it's called the Tower of London task because basically participants move discs from a prearranged sequence on separate pegs to match a goal state. And this is including intellectually impaired, so people with learning disabilities as well as neurotypically developing controls. Yeah, here we go. This is the graph. So you can see that the autistic children in black here only did it, like as I said, 10 to 20% of the time they got it right within the minimum number of moves, whereas these mild learning difficulty and normal controls were doing it at levels, for instance here, up to 80% of the time, mostly above 60%. So they're severely impaired at planning is the argument. They're also impaired at mental flexibility. So we have this task called the Wisconsin card sorting test. And again, this is a really famous task. We use it all the time to assess mental flexibility in psychology. So this is what it looks like. You get given a card, and the card can vary along multiple dimensions. So it can vary along color, it can vary along shape, and it can vary along the number of stimuli on the card, right? And then you have this card here, and you have to put it onto a different pile. You have 4 piles in front of you, and you have to put it on a different pile. But the rule changes. So at any one time in the task, first of all, you might be sorting by color, and you say, okay, that's yellow, so I'm going to put it on that pile. But then another time you might be sorting it by shape, so you're going to say, I'm going to put it on the triangle pile. Another time you might be sorting it by number of shapes on the card, so you put it in that pile, for instance. And people do this, and they get some feedback as to how well they're doing. You can see there it tells them if they're correct or not. But at any one point in the experiment, the rule changes completely randomly if they start doing it quite well. So if you're sorting by colour, all of a sudden it changes, you're sorting by shape or you're sorting by number. Theory of mind deficits. Can executive dysfunction explain the undoubted theory of mind deficits that autistic children show? Well, some people have said they can. So for instance, there's this theory called the cognitive complexity and control theory. And it argues that individuals must be able to formulate these complex reasoning structures in order to develop theory of mind, which you also need, which is like an executive function essentially. So this is from the paper, the Fry et al. Paper. It's a bad diagram because I could only get a PDF, but essentially it explains it better here. But you start with something, if something, and then you get another if something, then this is the outcome. So you have multiple different outcomes, for instance. And for theory of mind, if we're looking at the Sally Ann task, you might say, if we're working out the beliefs of Sally, and if she put the ball in the box, then her expectation is wrong, for instance, or like what she's just looked at is wrong. Like she shouldn't have done that. You need to say, if I'm thinking about Sally, if she's gone to the box to pick up the ball, then she's wrong, for instance. And it's also needed for instance, the Wisconsin card sorting task. So if I'm sorting by colour, if the criterion is unchanged, then I place the card into the green pile. If I'm sorting by colour, if the criterion is changed, then place the card into a different pile, for instance. You need these reasoning structures to do both executive functioning and theory of mind. And more recently, there was this paper by Muller where they found that this performance on the dimensional card change sort, which is similar to the Wisconsin task, was closely related to false belief ability in 3 to 5 year olds. So the idea is you need the same underlying abilities to do both. And this was when they controlled for age and verbal ability as well. And also there was no correlation with the false photo task, which lacks the if-then requirement. You don't need the if-then requirement for the false photo task. Inhibition may also be crucial for theory of mind, because it allows one to disengage from one's own beliefs in order to consider the mental states of others. So we have to inhibit. For instance, if we go back to the Sally Ann task again, we have to inhibit where we know the ball is if we're trying to work out where the other person thinks the ball is. We have to suppress those thoughts about where we know the ball is. So we have to have inhibition to do this task too. However, although there's this evidence that suggests that theory of mind ability might be impaired by impaired executive function ability, other people have argued the exact opposite. That in fact, we only find problems with executive functions because they've got impaired theory of mind. This is like a reverse causality. So this is, one of the ideas is called the triple I hypothesis.